let's discuss the cost of this mark and sweep system. What am I actually paying? Where's the problem? So first of all, notice that there is a counterintuitive thing going on. What that means to say is the following: the garbage collection algorithm pretty much goes over memory between 2 and 3 times, right? It marks it all, whether it does it during the actual runtime, garbage collection, or whether it does it throughout the life of the program. But it's marking somehow all of the memory blocks. Then in step number 3 is collecting all of the memory blocks which are 0, which means it went through memory exactly twice. And then the middle part of marking all the live objects, that could run anywhere between nobody to everybody, which means if everybody's alive, you'll be marking everybody. If nobody's alive, you're marking nobody, right? So we are running anywhere between 2 and 3 times over the entire memory. So first of all, that's already a big cost. And there's something counterintuitive going on. In a sense, you would work the hardest, which means 3 times over memory, when you actually reclaim the least. And you would work the least when you actually reclaim the most. Now, that's not a problem, but it's counterintuitive. If I go and I mark all of memory in step number 2, so in a sense, I reclaim 0 because everybody's alive. Now, that's just a fact you have to live with, but I'm just saying, but notice that you're working more and gaining less, which is something which is, as I said, counterintuitive. It's not a problem in the sense that the algorithm is not working, but you would expect something which is in line with the amount of work that you put in. You would expect that the more work I put in, the more memory I actually reclaim, and that's not happening here. Now, the bits of the indicator bits actually take up memory. There is a cost of the actual runtime of which actually doing all of this. Now, if we start talking about memory, which is not blocks like we talk about now, till now, we talk about actually different size blocks. So there's actually more costs involved. So for example, if I go and I take the memory and I split it, and I go and I say, okay, let's take different size blocks, right? So we go and we say, okay, here's my memory, and now it's consecutive memory. And first I allocate this block, right? And then I allocate that block. And then I allocate, I'm just saying, let's say, whatever, this block. Whatever. And slowly, I'm allocating more and more blocks, notice, right? I'm allocating more and more blocks. And then I have to figure out now, first of all, where to put my indicator bits. That's the first issue I got to talk about. Second, I think I got to talk about is that I have to figure out, which block as a block is, let's say, can be reached. Now, I can actually go and put data inside here. For example, this block is of size X and this block is of size Y, etc. I can do that. I'm not saying that, but notice it becomes a lot more complicated. Now, what happens if you reclaim memory? For example, let's say this block has been reclaimed, and so has this block. Now, notice that together you might have this amount of memory together to allocate, but we're getting here fragmentation. Meaning to say that even though if you try to allocate new memory and you need, let's say, this amount of memory, you can't do it. Even though, as far as empty memory is concerned, you have enough space. If you were just able to put these two guys together, right? So then you have enough memory to allocate. But unfortunately, right now you don't have. So this won't be able to, you won't be able to accommodate for this. You also won't be able to, slowly as memory it gets used up. So now you want to allocate some smaller piece. So this will be split into 2 again, right? And slowly you will get more and more fragments of memory as you go and you deallocate them and then collect them back. Nothing tells you that these two guys are actually one continuous memory segment. As far as the system is concerned now, these are actually 2 separate segments. And therefore, we are getting fragmentation, which is actually a problem.